A common misconception in the building business today is that simple air sealing, such as weather stripping doors and windows, sealing or caulking around outlets, can have a big impact on the energy performance of homes. But in reality, it's the design and installation of the HVAC system that can have a much greater impact. Today I'll be talking with Charlie Goman, who's with the Arizona Department of Commerce, and he's an energy expert there that's been spending a lot of time in his recent career doing research on how to do HVAC systems right. Hey Charlie, good to see you again.
Morning, Steve.
Well, I guess you've been doing a lot of research on this topic. Tell us what you've learned.
Well, we found two things out that really impact heating and cooling costs. The first thing is the duct systems themselves. They need to be installed tight, sealed, so that none of the air that you're heating and cooling leaks out of that system before it's delivered to the rooms. In a case like this house where the ducts are in the attic, if it leaks, you're cooling or heating the attic or the outside. The other thing that we've been discovering is that these systems can create a lot of pressures in the house that can actually force air out of the house or pull air into the house. What happens is when you have a supply system, a register that's putting air into the room, and you close the door to that room and the air doesn't have a way to get back out, it's like you're blowing up a balloon.
No return air duct.
Right, no return air duct. You're blowing the room up like a balloon, and any little hole in that room is going to leak air. And what happens with the rest of the house in that case is it's going to have a situation where it's going to be pulling air into the house, a negative pressure, pulling air into the house through all the little cracks and crevices. It really is a big issue is when you're having these situations in a house that has a fireplace or a water heater, some kind of a combustion appliance where these pressures are great enough that they overcome the draft. The smoke going up the chimney, it's great enough to pull that smoke into the house.
We call that backdrafting.
Backdrafting, right. And it's dangerous because it can have carbon monoxide in the exhaust, and you don't want that in the house. So
absolutely, that's an odorless, colorless, tasteless
right.
gas that can kill you.
Dangerous, right. It's the same stuff that comes out of the tailpipe. So that's what we're trying to do, is help the builders understand this and design the system so that we end up with a house that doesn't have any pressures. It's neutral. It works.
We think of a typical HVAC system in a home. We have an air handler unit or a furnace or an air conditioning unit that provides heating or cooling. We also have typically a return air duct, like say in a hallway, that tends to be a large grill-like device. And then of course each of the rooms have supply ducts. And of course if we don't have return air ducts in those smaller rooms, that's the problem.
Right. So we're working with them on a number of different ways to solve this, trying to get returns in the rooms, or else providing what we call a return path. It's just a path that the air can take to get back to the return in a hallway. We can do this with jump ducts or just straight pass-through grills, just a grill in the wall, or undercutting a door a little bit. But that doesn't seem to work because you have to undercut the door 5-6 inches, and that
doesn't look good.
That doesn't work.
Or a return air duct.
Yeah, return air duct. That's the ideal way to do it.
Well, I understand that you have some diagnostic equipment that can help us diagnose this.
Right. Let's go take a look.
What we're looking at here is a jump duct that we've temporarily sealed for our experiment. And just to review, kind of the concept is for a typical heating and air conditioning system, we have a distribution system that has supply and return air ducts. And typically in a bedroom, we'll have supply ducts, but oftentimes they do not put return air ducts in. So what that means is when people close the doors, the air from the room, pressurizes the room and doesn't have an efficient way to get back to the HVAC system to be reheated or cooled. So it really impacts the comfort. What we have here is a jump duct. Essentially what that is a duct that connects to the other side of the room. It's actually a duct that jumps the wall, and we have a grill on the other side. So in our experiment, we're going to actually use this manometer to see these pressure differences.
Right. What we're going to do with the digital manometer, with the duct tape, so it's like the jump duct is not there, close the doors and see what happens to the pressures in this room. See how much pressure is created by the air handler.
And again, this just simulates not having a duct in that room to return the air.
Right, right. That's all we're trying to do. And so what we need to do is just put the hose into the room, close the doors, and see what happens.
Now tell us, Charlie, what this manometer is actually doing.
In the simplest terms, it's just measuring the pressure difference between the end of this hose and the end of this hose. Right now we have the green hose is going into the bedroom, and the clear hose we have going all the way to the outside, so it's measuring the pressure difference between this bedroom and the outside. We're measuring around 2 pascals of pressure right now. Pascals is a measurement of pressure that we use. And so the air handler is pressurizing this room.
Now I can actually take this ladder here and go up and pull that off, and it should equalize the pressure, which means that the air now is flowing through the jump duct, getting back, and the system's going to be operating a lot more efficiently.
Right, what we're trying to do with these jumps and other types of return paths is just have a system that's not creating any pressure. And as we can see now, it's actually gone from a positive pressure now to a slight negative pressure, and that could just be due to some wind outside or something like that. But we're basically at a neutral pressure right now. We're below 1 pascal, and that's way within the range that we're shooting for here.
Now we can graphically demonstrate this with thermography. Now you've taken some thermography of actual air leaking into a system because of these pressure imbalances into a home.
Yeah, what I've done with some homes when it's really hot out with an infrared camera is close the doors and then just taking infrareds, when the doors are open and there's no pressures, and close the doors and let the system start pulling hot attic air in, and you can actually see the hot air being pulled down through all the little cracks and crevices in the attic into exterior and interior walls.
Let's explain why that happens again.
Well, what we're getting when the door is closed and we don't have a balanced system is the bedroom's positive, but this part of the house will actually go negative. It's going to be pulling air into the house, sucking air into the house.
From the outside through all the cracks and gaps.
Right. And it's really an issue in our climate because our attics are really hot in the summer. In a cold climate, you've got a really cold attic. So that's going to be pulling that air out of the attic in through all of the utility penetrations, the wire, the plumbing, and pulling it into the interior walls and heating up the interior walls. Or it can actually pull it into like an insulated part of the house and actually heat the insulation up. And then the insulation doesn't work as well.
Absolutely, and that all costs us money.
All costs money. The other thing that's interesting they're finding is the negative pressures also can pull air from an attached garage, for example. So if you start your car and drive out, close the garage door, the carbon monoxide that's in the garage may end up in your house. And it's just a concern that we really have.
Absolutely. They estimate as many as 500 people a year can die from carbon monoxide poisoning from
Correct.
problems like this. Mm-hmm. So Charlie, we can use a smoke pencil to also demonstrate the effects of air infiltration and exfiltration.
Right. What that allows us to do is actually see the air. You see the smoke in the air, so we can go to a window, for example, in a room that's pressurized, and we can actually see the air leaving through any of the cracks or crevices around the window. Or we can go to the fireplace and actually see if the smoke is coming down the chimney or up the chimney. It's a good way to visualize air movement.
Well, this is great information. Let's talk about now the solution, which essentially is return air ducts and jump ducts.
Correct. In this house, for example, we do have the jump ducts, so we've got a good example of these. And also in this house, in the master bedrooms, we do have ducted returns. So we've got both solutions in this house that we can take a look at.
Tips for installing these?
It's basically the jump ducts are a pretty simple concept. It's just a register with a boot with a flex duct that jumps the wall in the attic back into the hallway. A lot of cases you can bring a number of jumps into one central hallway return grill, combining them. There's some other solutions with straight pass-through grills, which we don't have in this house, which is a great solution for retrofit, where you don't have access to the attic or something. It's just a grill right through the wall.
Now the issue there is, of course, you can have some noise issues there you want to be careful of.
Right, you have light and sound issues there, but in a lot of cases you're limited to those types of solutions in retrofit if you can't get into the attic and put in a jump duct.
And of course we don't want to minimize the importance of sealing the ducts properly.
Correct. That's the utmost importance, is getting those tight, sealed with the proper material so that it lasts. You don't want to seal your ducts and then have the seal fail 2 years down the road. That doesn't do you much good. So it's really important to seal those ducts up and do it with the right materials.
What are those?
We like mastic, a water-based mastic. That's in all the programs we deal with. That's all we allow because it's very forgiving. It's easy to install, and once it's on, it's not going to come off.
Well, Charlie, this is great information. Thanks for joining us.
Thanks for coming, Steve.